Okay, last session of the day. Probably you guys have already exhausted, but probably it's helpful and worth coming here and attending. Nice campus. I love the greenery and the light, and would like to live here, I would say, but cannot. So starting our session, we come up with a session on SQL Server.
Counting. You keep going now.
All right. So we're going to differentiate MySQL Server, DataBricks, DataLake. Today's problem we have observed is that so many things to see and observe. What should I use, right? Should I use DataBricks, DataLake, or SQL Server? We started with SQL Server like 10 years back. If I go back, I don't know how many of us were using DataBricks or DataLake or even they exist. But I know SQL Server was there. SQL Server was there. I was mainly focused on Exchange server side, and we used to listen every single time when product group used to come and say, next time we will move Exchange database to SQL. And that never happened. That was a joke, but that's how I started with SQL. But moving on, moving on, thanks to all the sponsors and also the volunteers. We should not forget, all the volunteers came up last night, made a lot of effort, woke up early, set up everything, which you see, the coffee and everything. Thanks to them. This is myself. I live in LA. I can say now I'm in Ventura County in Simi Valley. I've been Microsoft MVP, wearing 2 hats. Global CDO for GoldenFive. We are US-based Microsoft Gold partner, and LA EXUG Foundation for my user group. Moving on, I want to tell that I work for almost all IT giants: IBM, Accenture, Microsoft, Wipro, TCS, Dell, something or other I've done in over 20 years. So. Now, on the other side, on remote, I have Ajit from Toronto. And Ajit, you want to take care of your slide?
Sure. Good afternoon, everyone. My name is Ajit. I have about 15 years of experience in the world of data. I've spent about a decade with Microsoft, working on SQL Server, data engineering, and data science, of course. Currently, I'm working with GoldenFive as a data architect and scientist. So feel free to reach out to me.
We are US-based, but we also have our office in Canada. He's operating in Canada. So obviously our sponsorship is coming from GoldenFive. Anything what Ajit is working over the weekend to cover this. I'm here. That's one's covered by my company. We are GoldenFive. Microsoft reseller for GCC, High, and DoD as well, as do other organizations. And we exist in 3 locations. Again, thanks to the community. If you guys need to connect, more than happy. So I can pause here. But probably you might have seen this slide earlier as well. And I can share, or you'll get it later as well. Future events, target it. This is Denver. You want to go to Himalayas, near to Nepal, or India, near Nepal. Plan a trip, go 2 places in one go. Also attend this event, right? And Orlando, who doesn't want to go Disneyland, right? So go Disneyland with SQL Saturday. Yeah, maybe the schools are open, so kids are not going in October to Disneyland. Might be empty. Yeah, who knows? All right, moving on. What is data? Anyone know what is data? What is the definition of data? Let me ask someone who wants to say, I know data. What is data?
Been you a while?
Yeah, I want to know, this is a open question. What is the data in your term? You want to say? Go ahead.
Just information the company cares about.
Yeah. Anyone else? What's that?
Any information, no matter who cares about it.
All right, anyone else? Any other?
Lots of information.
Yeah, so let's think of anything listed there in the data which could be useful, not useful for different people. Maybe I get an SSN number, what am I going to do? Nothing. For me, it's a waste. You give me your bank account user ID and password, what am I going to do with that too? If I transfer, you can track me, I'll be in the jail. I don't need that. So what is the data for me? It's nothing. Your data is nothing. I need a data, who's going to buy my software, right? If you sell me that, that'll be more useful. Okay, I'm selling these things, someone buys, that's useful data for me. So data is everything, but maybe not important for you. Your requirement data will be different than yours, and yours will be different to others. That's the data we are living in, and that we are realizing now, like maybe last 10 years, where all we left our data. Just think of it. How many times data breach I've heard and worried, oh my God, I left my data in Target and my data is leaked, or somewhere else. Recently, I just posted today, Twilio, which is a SMS connector provider. So they provide SMS service for your applications. They got hacked, and maybe you're receiving an SMS that send me money at this link. So it can happen. So now that they had the phone numbers of so many organizations which were using text message for their applications, now they might be getting those spams there. So data is good, bad, and useful. We're talking and discussing data queries and everything. It could be a huge data of an organization which is under investigation for any crime or bribery or anything, and maybe that you have to extract the data, some portion of the data by running huge query or huge database by running small query. It's all how you're going to manage the data is the next thing we're talking about. Being said that, I'll hand off a little bit to Ajit. Start with RDBMS.
Awesome. Thank you, Prabhat. Well, that's a good start, starting with data, isn't it? So, data for everyone, that definitely means something else. There's they're available in different shape and size and different types. Right? At this stage, we have structured data, semi-structured data, and we definitely have a blob, right? That is just like everything else. So traditionally, we had RDBMS, or let's just say it's the DBMS. We just added a relationship on top of it. So RDBMS, we had a couple of offerings, starting with SQL Server, my favorite. And we do have Oracle, or PostgreSQL, or MySQL. So if you really try to invest some time and try and understand what these database management systems has, well, these systems are designed for a very, very specific purpose, right? For example, SQL is designed for, let's say, structured data. Same goes for Oracle. Now, can we have semi-structured or unstructured data in them? Absolutely, there are provisions to do so. But then, it's not the best use case of a SQL Server. Prabhat, if you could go on to the next slide, please. Thank you so much. So if you would really look at what an database management system or the architecture looks like, There are, I would like to term them into, or rather categorize them into three specific categories, right? One is your various engine, or basically a logic that performs certain operations on your data, right? Query processing becomes one, optimization becomes another, and there's just lots and lots of them. Most important, or the heart of your database management system, is storage. Now, this may or may not sound right? So let's try and understand how storage is important. Now, imagine a database system like SQL Server. We have got a data file, we have got a log file. Same goes with Oracle. Now, what's so different about these data files? So, if you would know the architecture of your data file, they store data in terms of pages. There are different types of pages within the file, right? So the idea of having a specialized storage, or a special file that would store your structured data, is not something new. It's been around for ages, and the whole idea of having such a structure for your storage is basically to ensure we have a faster retrieval of information. And then there were certain protocols that needs to be followed, right? For example, write-ahead logging as one of those protocols that storage helps them, right? For example, your log file. Any data that's supposed to be ingested in your data file has to first go through log files, or rather it's logging being written in a log file before the data is actually pushed onto your data file. So there are various other terms. I'm not elaborating more on it, considering we are on SQL Saturday, and I expected most of you to know what the SQL or how it operates. So quickly I'll cover the other point, the compute, or in terms of SQL, I can talk about source scheduler, right? The SS scheduler, or the idea of having. So scheduler here is little different as compared to what the scheduler with other system may look like. Now, although SQL is just an application software, there is a layer, scheduler layer sitting on top that exposes the threads that can go around in your operating system to execute. So source scheduler is again a very specific piece of SQL operating system. That's the term we use. So it's a very important piece for your computation. Now, why are we talking about these three things in terms of architecture? So if you really look at the database management system, or the relational database management system, after a certain point, there is an issue in terms of scalability, right? If like how Microsoft says is 100 GB per data file. So if you would like to have your database grow to a larger size, they recommend that you partition your data and may have a multiple data file. So we are talking, and we are still talking about structured data. We've still not gone beyond structured data. So traditional RDBMS system has a little bit of I'd say restriction in terms of what we can really use. And in today's world, which is like ever evolving, we definitely have to go beyond, and just cannot rely on just the RDBMS system. Right? Okay, so moving on, Prabhat,
Okay, thanks. All right, that brings up to another question that what big data size you have handled or experienced so far. I would like to know how many, think of any data size, throw a number, and if you and the next person can say, I did maybe 1 terabytes or more. If someone said only 1 terabyte, and if you have handled, nothing wrong, but I want to know more that how much big sizes you have handled so far in the audience.
About one, two,
1 terabyte,
1 to 3.
3 terabytes. Anyone else?
7 terabytes.
7 terabytes. Anyone else has a bigger? 7? 10 terabyte? 10 terabyte 1? 2? Are we selling it? Douglas might have handled bigger. How big?
30.
30 terabytes? All right. So we have 30 terabytes people have handled. Ajit on the other side is handling a petabytes of size of data right now. That's why we want to know that how big you have handled and how could be your concern in managing those databases, right? Running a simple query on a petabyte size of a data could be lifelong running. And if it fails after that lifelong period, then you have to rerun it. So the point is, we have to still decide and pick up the right path so that doesn't fail or maybe right chunks. Right. So moving on, that's a good for ourselves. Moving on, Ajit, take over again.
Sure. Thank you. So, I'll quickly try and cover a few things about SQL Server. Prabhat, if you could go to the next slide. Well, SQL Server does not really need any sort of introduction, right? We all know the use case of SQL Server. Majority of it is OLTP. And so, what's the size you have really worked on in SQL Server, right? Managing about 500 GB of data is probably the max you would look at. Can we grow beyond? Yes, we can definitely grow beyond. We can even have a terabyte size of database. But I would not like to get into that situation, right? Imagine a database even one partition of my database going down. Trying to restore or perform any other operation is going to be an administrative nightmare. So the idea or the objective of having an RDBMS system is to have a more manageable solution, right? But we definitely want to have a system in place that performs quick. The operation has to be performed quickly. So that's where SQL Server excels. You would probably want to have your POS system, right, point of sale system, or any other, let's say, banking transaction or any financial transactions. So that needs to go through real quick. And having a SQL Server as a backend solution for your online transaction processing is an amazing idea. As your data grows, that's where the problem is. So what you would eventually do is have a data warehouse solution in place where you can offload all your old data. We're going to talk about those in a couple of minutes, but coming back to SQL Server, yes, the very first thing is we use it for OLTP system. Any application, any system that would like where you would like to have a better response time. Typically, the expected response time is within a second or two. Certain web-based applications may go at about 30 seconds as well. Now, those are not a very interactive system, so I would definitely stay off of them. But yes, you definitely want your system to be highly responsive. And using any RDBMS solution that supports OLTP is the right way to go about it. Now, the type of data that SQL Server supports, most of the RDBMS system is built around structured data, but that does not stop you from keeping a semi-structured things like JSON or an XML format. So SQL has started supporting XML and JSON. It's been quite a while now. But they are not as effective and natively supported like it would be in something like DataBricks. So that's the another thing. We are, for the most part, restricted with structured data, and that sort of makes sense if we are using an OLTP environment. Even for OLAP environment, data warehousing solutions, structured data is a way to go, but then there are certain use cases where you may not want to just have structured data only. And of course, we touched it briefly, the storage format, the files, they themselves has their own restriction, right? Now, how big can they grow? How much data can they really support? And how good are your PFS, IAM, GAN, and SCAN pages are? So that can ensure your data retrieval is at par. So these are some of the things which are really specific to, you can say, SQL Server, or some of it is definitely at large to the RDBMS system. So that's a quick about SQL Server. Before we move on, if there's any questions, we can definitely talk about it.
Any questions so far on SQL Server? No one has any questions. They're all on SQL. That's good. Perfect. Let's go DataBricks.
Perfect. The next thing is DataBricks, right? Based on Apache Spark. An interesting technology. It's available in Azure, it's available in AWS, it's also available in Google, I believe. I've not used it beyond Azure. There's just one platform is good enough because it's the native. If you would just use DataBricks, you would probably use it. Doesn't really matter if you use it with Azure or AWS or any other service providers. So, what is DataBricks really? So, DataBricks is basically an analytics platform. Now, DataBricks, to start with, you get an interface just like your Microsoft SQL Server Management Studio, right, where you can type in all the queries, you have some UI. Well, no UI here, but yes, we do have a good screen to start typing your queries, right? So, analytics platform which is specially focused on data science and data engineering. Now, I'm not sure how many of you are using, or you guys are into data engineering or into data science. But if you process, if you would need to process data for, let's say, a machine learning algorithm, right? So data is structured, it needs to be structured. If it's not, most importantly, data needs to be cleansed. And you would probably impute some values, you would probably remove some junk values, and you need to ensure your data is well balanced. So there is something known as target and balance, and how you can balance them. So Azure DataBricks supports most of data science and data engineering use cases. It still deals with structured data. So within Azure DataBricks, you do have an option to create a table. Yeah. Question?
I said bless you to someone. I think someone sneezed.
Okay.
Today.
Right. So I'll just keep going. So DataBricks offers a wide variety of support because it supports various languages. Okay. DataBricks supports Python, which is an amazing language if you would like to perform data engineering. So if you guys have worked using Python, I think that pretty much sums up the power of Python is it's really into its packages, and there are packages available for machine learning and data science, or there are packages available to perform the various tasks within the ETL or ELT framework. So Python is one language. It also supports R. So if R is definitely one language which gets the most updates first in terms of a new algorithm for artificial intelligence and machine learning. So it does supports R as a language. It has its own version of SQL, or the Transact SQL. So it is known as SparkQL, or the Spark Query language. And it's almost, or the syntax is almost similar to what you would do in what you would write in SQL Server. Of course, there are some variations to it, but then most of it still remains the same. So I think that's a very plus point with the DataBricks, right? You can use Python, and you can write a whole lot of code that can process any given piece of data. At the same time, you can be as procedural if you would like to use SparkQL. And the other good part about DataBricks is it does supports the creation of tables, and you can definitely build the relations on top of it. So that's just few of it. Now the other interesting thing is it's in scaled out architecture. Now presently I am using DataBricks in conjunction with DataLake to perform operation on a petabyte scale of data. Now so far I have used about 150 nodes to perform operation, and these operations they perform aggregation, they perform extraction of certain valuable information from the data, and they go on for like 4 or 5 hours processing at least 3 to 4 terabyte of data. How is that possible? Now imagine trying to do that within SQL Server. How do you think you try and run a select statement against a database, which and the select statement is supposed to fetch about a terabyte or 2 terabyte of data? It's really difficult. It's not something that can come back and tell you, okay, here's your data set, and you won't get an answer for like a couple of hours. Whereas DataBricks does it pretty smoothly, and depending upon how is your use case and how you have implemented a solution using whatever best possible options, you might as well get the data processing back in about an hour or so. So it really depends how you perform the operation. But the scale-out architecture here is really efficient. There is one master node, and you can start with one worker node, and you can scale out and go up to as many nodes as you would like. So it really spins up like the Azure DataBricks spins up VMs to perform your compute operations, and they scale up to n number of nodes. Right. So that is one difference than what we discussed in previous slides talking about the RDBMS system, right? They are really coupled architecture. There is memory, there is storage, and there is compute all in one place. Now, and plus with the given file structure, it may or may not be a right fit for the organization. Depends on your use case, but then if you would like your application to do the heavy lifting, you might not want to stick with SQL Server. So that's where the benefit of DataBricks is with the scale-out architecture, I can go and have n number of nodes. If I have a higher workload or if my processing demands huge amount of compute, I would choose DataBricks any given point of time over SQL Server. Now, we are getting a lot closer to concept of data warehouse, right? Data warehouse, okay, is basically a solution that was designed to store all the processed data on which you would really run an analytics on, right? So today's Synapse Analytics, SQL, or I would say a better version of SQL, is capable of performing much more than what traditional SQL does, right? So data warehouse is something, again, the key point in data warehouse is you store a processed data, whereas DataBricks is where you process the data. You would perform ETL operation on top of it, and at the same time it has a great integration with Azure, artificial intelligence and machine learning that can be utilized natively. Okay, and of course the other point is separate storage. Now each of the master or each of the worker node and one master node, they have their own storage and can definitely that storage be utilized to have a distributed data across all the worker node. But the idea really here is the master node picks up those processing tasks, whether it's an ETL transformation task or really some sort of extraction. Master nodes then distributes the data and it distributes the threads and of course the copy of your code that you have written, and they are then sent for execution onto your worker node. Whereas the master node keeps a track of how each and every worker nodes are working on. Okay. And one very good piece about DataBricks is all the operation is async operation. Now, what do I mean by that is whenever you perform an operation, right? For example, I create a data frame with the combination or by trying to join two data frame, and I use, let's say, an inner join, where I'm filtering out the data and creating a new data frame, or in terms of SQL, you might as well say it's a table. So that transformation is registered in the system and is not something which is executed immediately. Now, it becomes an async operation because then your master node can look at the registered transformation and decide what is the amount of data it has to work on and what is the expected output. It can analyze the registered transformation, and then it can distribute it among the workers. So that is an amazing feature of DataBricks, and the way it's beneficial for us as an admin is when you run a specific transaction, your UI is quick. Okay, it's like click of a button, you submit some transaction, and it comes back and says it's done. Is it really done? No, it is not really done. It's just going to perform that operation asynchronously while we can continue working further. So these are some of the great points of DataBricks, and yeah, with the different languages and support from data engineering, support of data engineering and data science piece is definitely an amazing thing to have.
So is DataBricks kind of like, so I don't have much exposure to it, so is DataBricks more kind of like an engine sort, kind of like a Snowflake or Redshift that does like that's like the MVP architecture of some sort, or is it kind of like
Is it kind of, did you hear the question, Ajit?
No, if you could repeat it, please.
So is DataBricks kind of like a Snowflake or a Redshift in AWS of some sort, or kind of like an MPP kind of like appliance of some sort, or is it like Hadoop? It's kind of similar to that? Is it just
Okay, got it. Well, you're absolutely right. Probably if I have to talk about the competitors of DataBricks, it's gonna be Snowflake, and Amazon Redshift is, I would say, more like DataLake. But yes, so Apache Spark, we earlier had an Hadoop server, right? Hortonworks is one of them. The problem with big data cluster was really they were traditionally designed for an on-premises system, right? You cannot really scale up and down the worker nodes. Now, since we have the world of cloud, right? The Azure and AWS. So that's where DataBricks can leverage and keep the worker nodes number go up and down depending upon the requirement. So yes, I would say DataBricks is sort of similar to Snowflake. Snowflake emphasizes a little more towards the ETL side. So there are a lot of transformations and a lot of functions and routines available with Snowflake to perform any sort of ETL or ELT sort of an operation. DataBricks does not just limits itself to that, and it goes beyond. And since it is integrated, the Python language is integrated, we get benefit of using things like pandas, or there are various frameworks like TensorFlow, Keras. If you're into data science, you would definitely benefit out of it. I hope I was able to answer your question.
All right. Ajit, can you turn on the video? I want to see if people can just see you with the slide.
Sure.
Use this presentation feature.
Mm-hmm.
So then, yeah. All right. I'll just switch to the next slide and bring other slides so you can keep going.
Question.
Oh, there's a question here.
So,
Okay.
Snowflake, with Snowflake, you can have data warehouse, and data lake. Can we have the same with DataBricks? Because there are differences between both.
Can we have
Data lake,
data lake,
data warehouse.
data warehouse with the DataBricks.
Yeah.
Data warehouse solution with DataBricks.
Yes.
Uh, there's like everything that is possible, but that's not really the use case. Um, we we do have a good storage. Databricks themselves have an hosted environment, so we definitely can utilize the system and have the data warehousing solution. However, Databricks was not designed as a data warehouse solution. So probably that's where Snowflake is a little better, and in fact, Synapse Analytics is also a little better solution. So I would rather use them rather than using Databricks.
Okay, can you once again come up with the advantages that come with DataBricks over the traditional online transaction processing databases? What are the advantages?
DataBricks advantages for online.
You mentioned that with DataBricks we have better scalability. We have it can scale up and it can scale down because it's in cloud, right? So
yes.
Consequently, it can handle with a tremendous amount of data, right? Is this the only one advantage that comes with DataBricks, which is against the...
Is this the only advantage, Ajit, or it's the more advantage of DataBricks?
Versus the RDBMS system, or?
Right.
Yeah, versus RDBMS.
Okay. Well, first thing, with RDBMS, you would probably only process structured data. But there are semi-structured, support for semi-structured data. In fact, I can even store some blob data if it's, if really need be, onto the SQL Server. But the native support for that is very less, and the performance is further deteriorated, right? So Databricks, you can use it against any data format. So for traditional structured data, there are external tables available. You can even create a table out of a base file. So if you have a, let's say a Parquet file, or if you have a JSON file, which consists of data, you can define your schema and create a table out of it and use Spark query language, which is pretty much similar to Transact SQL. You can use Spark query language and query it just like your SQL Server. So first thing I would say is you can process different types of data. It doesn't matter whether it's in structured, semi-structured, or even unstructured data like images can be processed and be used, but those are very specific to computer vision or under the hood of artificial intelligence. But it definitely can be used. The other benefit is you can process humongous amount of data. Like I said, I'm currently working on a project where I'm processing data at petabyte scale, right? That's something which you cannot do with SQL Server, at least with a decade of experience with SQL Server. I have never seen it happen and work as efficiently as it can happen with DataBricks. The other thing is, if you're processing such a huge amount of data, you would want a faster response, which SQL Server isn't just cut out to do it, right? So in that case, what DataBricks offer is an asynchronous transaction. So if I'm processing, let's say, 1 terabyte of file, What it really does is it doesn't goes ahead and process that file when I submit a command. What it really does is it submits a transformation. So like an example that I gave is if I am trying to join two tables using an inner join, I'm actually filtering out some data, and let's assume that both of these table or file, whatever you like to think of, is each of them is in terabyte in size. Now imagine the output may be closer to 100 gig or 200 gig or maybe even more, but then it has to process two files which are in terabyte in size. So that sort of a transformation is not very easy with SQL Server, right? So those transformation is a lot better with DataBricks, because when you submit those commands, it basically registers a transformation. What it really does is behind the scenes, it's going to take up those commands. The master node is going to analyze it. It's going to look through the objects it has to go through, and it will define how many number of nodes it would need to perform the operation. So there are n number of advantages that our DataBricks do bring on table, and definitely just like SQL Server can very well integrate with reporting services or Power BI, here we can use something like Seaborn or Plotlib, Matplotlib, and Plotly, and there's like various other plotting libraries that can be used to make an effective reports out of. So these are some of the advantages that which I think is worth mentioning.
All right, moving on, data lakes, and we have 15 minutes more, so we're gonna finish it off. I would request if you can hold further questions until we reach to that question slide now, so that we can finish on time, and probably if people wants to go at 45, they can go and we can continue the QA session after.
Awesome. So a data lake probably brings us a step closer to what a data warehouse is, right? Data warehouse is basically a solution that was designed to keep all your process data, right? So if I'm using SQL Server for my OLTP environment, I would probably use SQL Data Warehouse or Synapse Analytics as my data warehouse solution, or maybe even I can go Snowflake, right? So that was the whole idea of using data warehouse. Data is already processed and data is available in huge quantity, but then most of those data is structured data. That's number one. And number two, the data is already processed. So there is we have a very specific subset of data. Maybe that data is collected over a period of time, so there is a huge amount of data, but then still it's a subset. Now in this case, when we talk about data lake, it's all about storage. We don't have any engine running on top of it. We don't have any logic built on top of it. The whole idea of having a data lake is basically have a big enough lake where I can dump anything and everything that I want. All right. So it benefits. It's beneficial for a system like DataBricks, like Snowflake, and even Synapse Analytics. You can connect data lake to almost anything possible, right? The idea of having a data lake is basically you're trying to keep everything in there. You don't have to store any process data. You don't have to perform any operation. on the data to store it in a data lake. No, absolutely not. Um, all you need is a Microsoft storage account, and all you would do is just go on and have a hierarchical namespace configured that really started with Data Lake 2.0, but I think it's an amazing feature to use. And you can start storing the information. And there's really no limit to how much data you can store. Like right now I'm using it for a petabyte of data transformation. The good part or the amazing thing that Data Lake has is exceptionally fast performance. Now, if I need to query and pull a data file which is about a terabyte in size, I would probably put it in hot tier and I just fetch it. And my DataBricks system running on the front end would simply think that file is locally available to the cluster. And the other thing is there are really four different types which is available. That's file, table, queue, and blob. File is more like Active Directory integrated, wherein you can use that for file share. Table is more like an external table that you may be aware of in SQL Server. And queues are more like MSNQ sort of in format where it's all stacked up. And blob is really about anything else. So if your use case does not fall under file, table, or queue, you might as well just dump it in a blob. So that's what a data lake is all about. It's just a storage technology with an amazing performance at hand. So that is a quick about Data Lake, and the best part, as I've mentioned, is it goes, you can connect it all across, just like an S3 bucket in AWS, right? So quick comparison, when you would do what, right? For SQL Server, my goal is if I would need to store or have an OLTP sort of environment, I recommend that you use SQL Server. Data needs to be structured, of course. These are some of the best use cases for SQL Server. I have a structured data which follows a specific schema, and I know my database size won't grow huge, but at the same time I need an amazing performance, so I might as well use SQL Server, which has a good transaction capabilities. And of course, it just uses Transact SQL, probably the only language it uses. I mean, yeah, there are other languages that we can use, but Transact SQL still remains the primary language. DataBricks is primarily, we can use it for any sort of data. It doesn't really matter. So if your use case is beyond structured data, and you have to deal with various files and blobs and images, it all really depends what you're really trying to do with the data. If you're to perform an ETL operation, DataBricks is a good choice. If you really want to perform, if you would really like to train machine learning algorithms, again, DataBricks has a lot of libraries in place with the help of Python and R as a language to perform the required operation. The amazing part of DataBricks always been the multiple language support is simply amazing. And of course, SQL Server is in coupled architecture, right? We have everything within one application, whereas with DataBricks, everything is scaled out. So we can scale up and scale down as much as possible. So there is no limit to the amount of data processing that we can really perform with the help of DataBricks. Data Lake is ideally different from all of these, right? We can just store anything. Basically, it complements your DataBricks or your Snowflake application. It has a large storage, we can literally go on and on, store as much information as we would like. And the best part is it's accessible. You can, it has an amazing API system, and you can really connect it with any and every system available across. So that's what I would like to talk about in terms of database, DataBricks, and DataLake. Use cases, I believe most of you would be aware of it. Well, we can, so one use case which I see is not something which probably DataBricks can perform, or for that matter even Snowflake can perform, is CRUD application, right? Create, read, update, delete, highly relational system, and has got multiple level of normalization. That's not the use case for DataBricks or Snowflake, or for that matter even in Azure Synapse Analytics, right? SQL Server is good as long as we are in the vicinity of 100 to 200 gig of data, because the more normalized your data is, the more objects you are going to touch, and more problem in query processing. And more number of data definitely affects how your SQL Server optimizer gets a plan for you and process the data for you. Okay. So, yep, that's a little bit about the use case.
Ajit, you want to tell something more about like DataBricks, and you are working on petabyte size of the data. So if you have to run a query for a month of data or maybe a year of data, how much time it can take, like extraction timeline? Versus maybe, do we have similar thing in the SQL Server or DataLake, how they help each other or something? Or work differently?
Yeah, absolutely. So I can definitely talk about the use case which I'm currently dealing with, right? So we have a data which is available, approximately a terabyte of data for each day. So if you're talking about a month of data, I'm talking about data in the vicinity of 30 to 35 terabytes. Okay. Now, to be able to process this data, I definitely cannot imagine SQL Server doing it, right? 30, 35 terabyte of data. Although the data is not just, it's not just about the size, it's also about the width of data. This particular data has got 151 to 158 observations. What in SQL Server language you would generally term it as columns, right? So this data is wide and this data is huge. Okay. Now this data is stored in a different format. Now I cannot store 30-35 terabytes of data in SQL Server. I cannot imagine my MDF and LDF growing that big, right? So this has to be broken down into multiple files. Now, in spite of trying to break it down to multiple files, it's still not manageable. It's still a huge amount of data. So the other option is compression. So there's this amazing format known as ORC format. So ORC format, basically it's an optimized row columnar. The amount of compression is about 25 times to what you would get in a normal data compression. So that's how data is stored in the data lake, which is about terabytes and terabytes in size. Now, if I process the 35 terabytes of data using DataBricks, I'm still looking at about 12 to 15 hours of operation. And provided I'm restricting my number of nodes to 100, so I've got 100 worker nodes, each of them have got like 32 GB of memory and about 8 core processors, and these are all high-end machines running. So they would
Those are the
still take
master and
about
worker nodes, right? You're talking about?
correct. Correct. There would be just one master, which is plenty enough to take care of this particular transaction. And there's about 100 nodes. Now with SQL Server, I just cannot imagine. I mean, how many databases will I even run at them? So that's the I would say the type of task which can be performed by things like DataBricks.
All right, that brings us to the time as well, and that brings us to the slide endpoint where we are open the floor for the questions. Please go ahead with the questions. I have some computer screen closing things here, so whoever needs can pick up. And yeah, go ahead.
How would you decide between using Python as a language or R as a language, or what are the pros and cons?
The question is, how would you define which language to use, Python or R or any other language?
Sure. So the interface that DataBricks offer is very similar to, I don't know if you've used Jupyter Notebook. It has a very similar interface, and before you start writing your code in our language, you just right at the top you would specify $R. And DataBricks also gives you an option. There is a drop down right at the right end of the cell. You can click on the drop down and select the language. So your one notebook can definitely have multiple. So basically there's one notebook. That's what the structure looks like. And the notebook comprises of multiple cells. Each cells can have their own language, and DataBricks is smart enough, you can execute all of them together. It will process one cell with, let's say, Python, the other one with Spark SQL, and the other one with R at ease without any issues.
Yeah. Did he answer your question?
Partially.
Partially,
I
yes,
just
sir.
wanted to understand what are the pros and cons, like how
He wants to know
decide
more on the
how
pro
to
and
use
cons.
Python.
She wants to know more on the pro and cons. Do you have more things?
Yeah, pro and cons of using one language over the other. Well, it's if you have an use case of, let's say, artificial intelligence and machine learning, my first go-to language will be R, because all the new algorithms and everything new that's being researched and is right out of the industry is first written in R as a language. The other good part about R is it's in statistical language, so it is much more performant than even Python. Okay, so if you are writing, let's say, code to process a data in Python versus to process a data in R, you should at least see a difference of 1 to 2 seconds executing in R versus executing in Python. And yes, with R you always get the latest and the best. With Python being an open language, it does take some time to port those algorithms and bring it in Python. So these are some of the pros, I would say, of using R. Cons, not really. I mean, if you're using it for AI/ML, that's the best out there. The only cons that I can think of is it has a steep learning curve. Okay, the syntaxes are really weird, and it takes a good amount of effort to learn R as compared to Python, which is almost like an English-like language. So if you can speak English, you can write Python. That's how I take it.
Still, his email ID is here. I brought up in front. My card is here. You can take it. If you still have some queries, you can feel free to write us. Go ahead. This is conflict. So he asked for first.
So, at a very high level, would you consider that DataBricks is more of a query engine solution that can be coupled with a DataLake strategy? Is that fair to say?
You hear that?
Absolutely.
Yeah.
Yes, absolutely. You can think of data lake as a query engine is what you would term it in SQL Server. Data lake goes for storage, and the master and slave nodes are basically your compute. The objective is to decouple them so that it can be scaled up and scaled down as per your necessity and definitely your use case.
Good. Oh, okay.
So what's the difference between DataBricks and the Azure Synapse?
What is the difference between DataBricks and Azure Synapse?
So Azure Synapse Analytics is, you can say, sort of they're playing in catch-up in terms of what Databricks already does. So Synapse Analytics has its background from data warehouse, whereas Databricks was more of an analytics, data engineering, and data science sort of a solution. So if you would like to, the good part about Synapse Analytics is they are also scaled out. So you would run with multiple nodes, and they are also distributed, almost like a Databricks. Very specific TransactSQL is used as a language. Structured data is still, I would say, the majority of your Synapse Analytics. Can we go unstructured and semi-structured and non-structured? Yes, we can. But the engine behind the scenes is still more structured. So that's not the case with Databricks. With Databricks, since it has an integration with R and Python, you can even run an image processing and do a computer vision sort of a use case. So that's where it's different as compared to Synapse Analytics.
Is Synapse more like an ETL tool then?
Synapse is more like an ETL tool then?
Well, for ETL, you would rather use Azure Data Factory. So think of it more like a data warehouse solution where you can create like a star schema or dimension tables, and you can use it to store a huge amount of data. More in an OLAP sort of a setting. So you can run reporting on top of it. Not really ETL, I would say. That's not the best use case. But it does integrate with Azure Data Factory to meet the requirements. So the objective is, if you really want to store data in a data warehouse solution, you would process it first and then bring it into the system. Whereas Databricks can perform ETL solution for you and use data lake to store the data.
Any more questions? All good? All right. These are our other social connectivity places where you can connect. I'm recording all the sessions, so probably I'm going to add to our YouTube channel. You can review if you need to. We have also the Azure user group and Exchange user group. We'll be starting to host the meetings again after COVID in Microsoft Office. So, all right, thanks everyone.
Thank you everyone. Have a good day.
Best wishes to win to everyone.
Thanks, man.
Yes.